So our next speaker is Mr. Udana Bandara. He is a PhD candidate at University of Canberra, Australia. His current research focuses on the biomechanical impact of lower limb joint and whole body stiffness on cricket fast bowling performances. He has obtained his master's degree by research in the field of exercise and sports science, sports biomechanics at the University of Newcastle, Australia. His primary degree, he achieved BSc Special Degree in Sports Science and Management at Sabaragamuwa University in Sri Lanka, and a diploma in Exercise and Sports Science at the University of Peradeniya. Moreover, he is also a former national athlete in Sri Lanka cricket. So I invite Mr. Udana Bandara at this time to share with us motion capturing in sports. He is going to focus on optical systems and why do we need this for current Sri Lankan settings. Over to you, Mr. Bandara.
Thank you very much. Very good evening. It's 9:20 here in Australia. Thank you very much for the nice introduction. I would like to correct a bit. I'm not a national cricket player. I'm a former national karate player. I wish if I were a cricket player. First of all, I would like to express my gratitude to the organizing committee for having me here today for this workshop. And I will be talking about motion capturing in sports. And there will be some sort of repeating things, but I think you all will consider it as a revising what we already talked through through. And so I'm Udana Bandara, as you all know, from the Research Institute of Sports and Exercise, University of Canberra, Australia. Before I move on, after interesting talks, a lot of engineering and clinical aspects, I would like to take your attention to the sports. Why sports science is essential to the development of sports. As a national athlete, when I say to people, I study in sports science, usually the question that I get, do you play sports in Australia? So everyone think when we do study about sports science, they think we play sports, which is totally the awareness of the essential of sports science is much low compared to other field. So I will take nice example why we need science into the sport. So if I ask from you who is the GOAT of the sprinting, without any doubt you would say it's Usain Bolt, who hold the world record for 100-meter dash with 9.58. Similarly, if I ask from you whether you know about Jesse Owens, who won the Olympic gold medal in 1936 with 10.2 seconds. So Usain Bolt made it his world record in 2009. So after 73 years, it still is not less than a second. The David Epstein, the author of the sports gene, he stated that if Jesse Owens compete with Usain Bolt in 2013 World Championship, Jesse Owens would still have 14 feet to run when Bolt crossed the line. And further, he explained it through the biomechanical analysis of Jesse Owens' mechanics. If Jesse Owens ran the same surface as Bolt, he wouldn't have been 14 feet behind. He would have been within one stride. So that's what science have done to the development of sports so far. So therefore, sport is no more a game of coach and athletes, but combination of number of stakeholders. Yeah. So biomechanics, sports biomechanics is one of the major field of sports science that plays a significant role in the current context of sports context. So what is the primary goal of sports biomechanics is to improving athletic performances by identifying and applying optimal techniques, prevent injuries, and speed up recovery. Also energy conservation through the economy of movements, but not limited to that. There are another wonderful way that biomechanics can help the sport. Let me to explain this in a nice example. When we see all these stats, we all feel proud, no doubt about it. But this wasn't an easy task for Murali because he had lots of challenges to overcome, not only from batsmen, but also many others. One picture says 1,000 words. I no need to tell any story about this. We all know the story. They challenged him. And this legend step forward to protect him. But there are some unsung heroes. They cleared him through biomechanics. So that is another wonderful stuff that biomechanics can do to sports. So it can check the legality of the actions where it's applicable, especially in cricket bowling. So why motion capturing in sports? I will be repeating a little bit of things. So it will be revising what we already taught, what we already learned throughout this session. So analysis of human motion is considered as one of the most precise technique to address elite sport outcomes. So there are two main methods, as you already know. The one is video-based approach, and the other one is automatic tracking motion analysis system, or as we call it motion capture, or simply we call it mocap. So video-based approach is cameras are used to record athletes during training and tour competitions and provide them eccentric visual feedbacks. So feedback can be derived as soon as they finish the task, or maybe after manual digitizing, they can give the feedbacks. But motion capture. So what motion capture does is the tracking and recording human motion in real time without delayed digitizing process. So there are three motion capture systems, as you already know. So I will quickly revise a bit of Dr. Orion pointed out in his keynote speak. So optical system, non-optical system, and markerless system. So as the optical system is the system that mostly has been used in the field of sports science, I'll be focusing a bit deeply about it with some examples and of an actual project, how we use optical system in sports science. So optical system, as we already know, we are using multiple high-speed cameras. We'll be using different positions and angles. So to capture the motion of an object via optical motion sensors and triangulate 3D positions in the motion of the object. So you can see there are different cameras in the roof as well as in the ground in the tripod in different heights. And these markers, so these cameras need to be calibrated to acquire quality and accurate data. And so there are two mocap systems, passive reflective markers as well as active reflective markers. So these systems track either passive or active reflective markers and place in the body landmarks and triangulate their 3D positions. So usually, as Dr. Orion said, we need minimum 8 or more cameras to have a full body capture system. So optical marker system, how does it work is, passive reflective markers, as we said, we have a system that uses passive reflective. It comes with the passive markers that coated with reflective materials. So these reflective materials will be captured through the camera through the infrared lightings. And it track this, to track these markers, at least 2 cameras should be captured at a given time. So this process creates unlabeled set of point or trajectories in the 3D workspace. So we need to have some post-processing tasks to require identified and classify and provide a meaningful 3D outcome to those trajectories. And the active marker system, very similar, you all know. I'm not going to spend much time on this. So this system have the active markers, which is instead of passive reflective markers, they use active markers, which is act as a light. And often these are infrared light emitting diodes. So we call RE LEDs. So camera filters all lights except these LEDs, and it create the unlabeled trajectories. So next, I will talk about motion captures hardware optical systems that we have. So we need to have cameras or digital high-speed cameras, and also we need to have markers, active or passive, and also we need to have a calibration tool. So we need to have the runs and the L-frames, and also we need to have the synchronized box to synchronize all these cameras into one position. And also we use integrated force plates in integrated system. We can use this integrated system with mocap systems. So force plate is, we use force plate for the measure the ground reaction force. In these force plates, we can measure 3D ground reaction force. We can get the full ground reaction force on all 3 axes, and also it create the resultant force too. And as earlier we said, the capturing operating software is the most crucial part in the motion capture. So there are different softwares that we can use. So I have 3 examples given. So I'm not promoting any of these things, but I just wanted to tell you there are 3 things. So the QTM is developed by Qualisys, and also Nexus is from Vicon. in MERCon, they have different systems, like for Lexus is for the life science, and also they have different system for animations like entertainment purposes and also engineering purposes. And there's OptiTrack. The motive is comes from developed by OptiTrack. So capturing software is as crucial. So we can use any of these capturing softwares with the given hardware systems. And next, once we collected the data, as you already know now, we need to model these things. So there are a few modeling options. So Visual 3D professional software is developed by C-Motion. It's a biomechanical analysis toolkit that we can analyze all kinetic and kinematic data. And also ProCalc is a Vicon product that developed by Vicon system. And also Mortex, DFlow Mortex it's another enhanced Visual 3D programming tool. And also we have the motion monitor, which is known as very popular in the sports sector. And it's provide real-time solutions, and also it's capable both monitoring and enhanced performance factors. And also, as you already know, there's a freely available softwares, which is OpenSim. And also, if you are good with language, you can use MATLAB, Python, or whatever things to model your all 3CD files and all the data that you collected from the motion capture system. So let me to share with you the actual project, how we use this motion capture system to collect sports science data in sports science. So this project is about cricket fast bowling. So based on actual project conducted at University of Newcastle in Australia. And we collected the data of junior New South Wales representative cricket fast bowlers. And so in this system, we use Qualasys hardware system, the cameras, and also we use QTM track manager system. And then to model, we use Visual 3D professional V6 professional software. So what we did is here, we use 16 motion capture system, and we measure them at 500 Hertz. And also we use 3D ground reaction force. We use cluster force platforms. So we measured at 200 Hertz of the ground reaction forces in this. And also we use smart fusion timing gate to capture the approach speed of the fast bowlers. As I said, I will show you a video. So we need to calibrate the camera. So once you calibrate, you can see the video. We can get the capture volume. So you can see there's no spaces. So this is the volume that you're going to capture your participant, the activity. So you can have a clear picture of this. So once you calibrated this, you are ready to collect the data. So if you are not calibrate this properly, you would not able to get clear and accurate data. So next, I will show you what we did. So we did in this one, we used 72 passive reflective markers, attached the anatomical landmark of the participants, and then we got them into to do the statistical trial. You can see that there is a ball. We attach the markers to the ball, to track the ball. And once they did the statistical trial, we got them into the actual experiment. So you can see me here with the low hair those days. And in this one, we use different marker sets. So 72 markers. So you can see these are the markers that define this particular segment. So we have 3 different types of markers: dynamic, static, and the clusters. So static markers will be taken off after the statistical trial. So when they do the dynamic trial, they will be having only the dynamic markers and the clusters. So there are few different marker systems that you can use, UWA, as well as plugging in Gait marker placement systems. And there are plenty that if you like to use, you can use. So here I will show you the video how we get the actual trials. So we got them to land on the force platform, their front foot contact on the force plate. So there will be a slow motion video. You can get an idea. So they landed their front foot on the force plate. So this action will be captured through all these 16 cameras, and you will get and then we will get a this sort of unlabeled trajectories. You can see the ground reaction force on the once they land, so you can get see the ground reaction force, how it comes. So then you can see it in different angles too. So you can see it all the angles. And then we have to label those unlabeled trajectories. So first we will label these statistical trial using the QTM track manager system. So once you labeled, you can rotate around and you can check all the markers have been labeled. And once it's done, you can move into the actual trial, the fast bowling trial. So then you label that. So you're going to label all the hands and all body. So all the markers, all 72 markers that you already attached to the participant's body. So you have to label the balls, and then even you can check it everywhere like that. So once you've done that, then you can develop the model using Visual 3D. So then once you develop the model, you can get all the data that you want in X, Y, Z axis in the all angles, showing all kinetic and kinematic data. So this is how it works in the system. So I will summarize. So you will get this unlabeled trajectory data from the motion capture system. Then you label it using the particular softwares, and you will use the modeling software to model it. Then you get the data that you need. So in the cricket fast bowling, we use 5 different phases to analyze. So you have to find out which stage you're going to analyze the particular motion, whatever the sport activity you do. For an example, if you want to analyze bowling action, like ball legality, you have to analyze the arm horizontal and the ball release. So you should have to understand. So it is a very short period of time and very quick movement. So we need to get the data from at the arm horizontal and the arm ball release. So this is the critical point where you check the ball legality actions. But if you want to check the ball in action, so you need to have the shoulder pelvis separation angle at the back foot contact to the ball release. So you have to have all 5 different stages of the delivery stride to measure fast bowler. So I will stop from here to about the motion capturing, but I will quickly go through these other systems that we have. I'm not going to deep down this because I think next person are going to talk about more about the wearable system. So there's an non-optical system. In this system, sensors attached to the body segment is to acquire the data, regrading the portions in the sensor space. So there are 3 methods: electromagnetic, an inertial system, and also mechanical system. We are not using much in sports. So this is a being low cost, and you heard enough of this system so far. So this is electromagnetic system that already discussing the thing. So this system compromised with small electric coils, well defined in electromagnetic fields, and athletic movements are tracked when coils generate a small voltage or current inside the constant magnetic flux. So, and also there's another system called IMU. You already heard a lot enough of this. And so initial measurement units, this system use based on accelerometer and usually combined with gyroscope and the magnetometer. And initial system data is often transmitted wirelessly to the computer in a real time in 6-degree freedom of sensors, or some gives a 9 degrees. So all 3 axes, along the axis and around the axis. And there's a mechanical system which is applicable in the motion capture system, but it's not using in the sports sector because this exoskeleton limits the natural motion of the body. So it's not much applicable in the sports science. And there's another system, as you already know, markerless systems, or computer image processing is emerging to reconstruct 3D motions from the video and other sensors without subject needing to wear specific equipment to track. So mostly they use in kinetic cameras. So kinetic camera that use infrared depth sensors have ability to track a real-time motion without needing any markers attached to the body. But however, these things, the frame rate is like 30 frames per second you could get maximum, so which is not much enough in my sense. So there are a few softwares that you can use, SIMI as well as IPI softwares. And also, before I wind up, I would like to share some nice studies. I think you better to read these things, which is as you all guys looking for developing new methods and new systems that we can affordable or applicable systems to Sri Lanka. So action sports cameras, as instrument to perform 3D underwater motion analysis, which is really nice article. They use only this GoPro cameras very easily accept. It's not that cost, so. And they have used the WAN-based calibration method, consists of 2 accession, 1 static, and also 1 moving WAN structure. So which is nice study. I highly recommend to go through it. And also they have nice conclusion with the applicable of these systems to the 3D motions. And also there's another study comparing with the OptiTrack. It's cost around 15,000 to 20,000 US AUD. When it consider the university level, my feeling is, yes, it's affordable in the organizational level. So they have compared with this OptiTrack with the Vicon system, which is another highly used mocap system. So here that's it from my side. So thank you very much. And if you have any questions regarding sports science, I'm more than happy to share my knowledge. And so I will be available on my email address, udana.bandara@canberra.edu.au, and also I will be available in those social media. And thank you very much. If you have any questions, I'm more than happy to answer if I know.
Thank you, Mr. Bandara. That was actually quite an interesting topic. We do have a question for you. What resources are available in Sri Lanka for the stuff you were talking about, and some things like the kind of Connect software and other resources available, and are they open source? Are they freely available? And what's the, I guess, affordability of such technologies?
Yeah, it's a good question though. Yeah, for my understanding, I don't know what sort of softwares currently we do have in Sri Lanka, but I know we have one Vicon system in Sabaragamu University. I don't know whether it's using or not, but I'm pretty sure they have one system in Vicon system that they can use if they want. And also I had I have talked with Dr. Pooji in several times, so we can use IMU systems to measure these things. But the problem is here in sports science, most of the activities that we have, they're high speed activities. So, but if, as Dr. Orion said earlier, people using Kinovia or maybe Tracker, they can use as a 2D analysis system. But so far we don't have, for my understanding, we don't have any other 3D motion options available in Sri Lanka, except that Vicon system that Sabaragamu University have.